Zero trust starts from a simple assumption. The network is already hostile, and nothing should be trusted just because it's inside a perimeter. That breaks the old model where a password and a VPN were often good enough. In this course, we'll look at how modern identity, strong cryptography, and PKI let us move from fragile, reusable passwords to phishing-resistant access. You'll see how certificates, keys, and device identity become the new control points for verifying who or what is requesting access, every time, rather than relying on static secrets that attackers can steal or guess. Before we go deep into PKI and certificates, we need to be clear on the problem they're solving. Traditional password-based authentication creates a silent, ongoing debt for organizations. Users tend to pick weak or reused passwords. Attackers know this and automate guessing, phishing, and credential stuffing at scale. Even with MFA, many implementations can still be socially engineered or bypassed. On the operational side, IT teams pay heavily. Endless password resets, account lockouts, and incident response after compromised credentials. Users deal with friction, yet security is still fragile. PKI and modern key-based authentication are a direct response to this cycle. By moving trust away from shared secrets like passwords and toward cryptographic keys and certificates, organizations can sharply reduce hidden costs while increasing security. Public key infrastructure is the system that lets us do on the internet what governments do with passports in the physical world. Instead of asking you to prove yourself with a password you made up, PKI relies on a trusted authority to vouch for you using cryptography. A certificate authority issues a digital certificate that binds a public key to an identity, such as a user, device, or website. When another system sees that certificate, it's really asking, do I trust the authority that signed this? If the answer is yes, it can trust the identity and the key, without ever sharing a secret. So the foundation of PKI is the trust anchor, confidence in a known authority, not in something a user remembers. Passwordless authentication is one of the most visible ways PKI shows up for end users. Instead of typing a password that can be phished or reused, the user proves who they are with a cryptographic key stored on a smart card or hardware token. The key never leaves the device. When the user needs to log in, the system sends a challenge, and the token signs that challenge with its private key. The server checks the signature using the corresponding public key in a certificate it already trusts. A simple local PIN just unlocks the token. It's never sent across the network. So what travels over the wire is not a secret password, but a signed proof that only the legitimate key holder could have created. This model dramatically reduces credential theft, aligns with zero trust by strongly binding identity to a device, and shows how PKI can enable secure, user-friendly access at scale. Most organizations still rely on shared secrets, passwords, OTPs, or API keys that both sides know. Anything that can be typed, phished, guessed, or copied will eventually leak. PKI changes the model. With asymmetric cryptography, the private key never leaves the device, and the server only sees the public key and a signature to verify. There's nothing reusable for an attacker to steal, from a login page or a database dump. That shift not only raises security, it also improves usability. The user experience can be a simple tap, smart card, or biometric unlock, instead of remembering complex passwords. From a governance perspective, PKI also centralizes control. You can issue, expire, or revoke certificates under policy, and quickly update who and what is trusted across the environment. Passwordless authentication is where PKI becomes very tangible for web and cloud access. Instead of a user typing a password that the server has to remember in some form, FIDO2 and WebAuthn rely on a key pair. The private key lives on the user's device or hardware token and never leaves it. The public key is registered with the service. When the user wants to log in, the service sends a challenge. The authenticator proves possession of the private key by signing that challenge, often unlocked with biometrics or a PIN. The server verifies the signature using the stored public key, and that's enough to grant access. Notice what disappears. There is no shared secret sitting in a database waiting to be phished, reused, or dumped in a breach. This aligns strongly with zero trust principles. Every login is a fresh cryptographic proof, bound to a specific device and origin, using open standards that work across browsers and platforms. When we talk about trust models today, it's helpful to separate classic enterprise PKI from newer approaches like FIDO2 and WebAuthn, because they solve different problems. Enterprise PKI is built around a central authority your organization controls. One or more CAs issue certificates according to corporate policy, and those certificates identify users, devices, and services across the internal environment. That model shines for VPN access, Wi-Fi, managed laptops, and server-to-server TLS, where you want consistent rules and strong governance. FIDO2 and WebAuthn flip that around. There's no single global CA you manage. Instead, each user registers a credential directly with a specific application or service. The browser and authenticator handle the crypto, using public keys behind the scenes, but the protocol is web-native and scoped to that site only. This is ideal for SaaS, external partners, and BYOD scenarios, where you can't fully manage the device, but still want phishing-resistant, passwordless login. In practice, modern zero-trust architectures usually need both: centralized PKI for infrastructure trust, and FIDO-style credentials for user authentication at the application edge. Now that we've covered the basics, let's compare security strength across three models: passwords, PKI, and FIDO2. Passwords are fundamentally weak because they're shared secrets. Users reuse them, attackers phish them, and once a database is breached, the same password often works in many places. You can add complexity rules and MFA, but the core weakness remains. Something the user knows can always be stolen or guessed. PKI shifts the model. The private key never leaves the user's device or secure hardware, and authentication happens by proving possession of that key. There's nothing reusable to type into a fake website, which makes phishing and credential stuffing dramatically harder. When integrated with enterprise identity and policy, PKI already delivers strong, high-assurance authentication. FIDO2 takes these same cryptographic ideas and standardizes them for the web, focusing on being phishing-resistant by design and very user-friendly. In practice, many modern strategies combine PKI for enterprise infrastructure and FIDO2 for end-user logins, moving away from passwords entirely and aligning much better with zero-trust principles. In a zero-trust world, authentication is no longer a single gate you pass through once. It becomes a continuous signal that's evaluated over time. PKI plays a key role by providing strong cryptographic identity for users, devices, and services. Certificates or FIDO credentials prove who or what is trying to connect, without relying on shared secrets like passwords. That identity signal is combined with device health. Is this laptop managed, patched, encrypted, and connecting from a known posture? Both inputs flow into a policy engine. The policy engine makes dynamic decisions. Allow, deny, step up with additional checks, or limit access to only certain actions or data. Every access to data and applications feeds new context back into the loop. Behavior that looks risky can trigger tighter policies or re-authentication. PKI is therefore not just about issuing certificates. It's one of the strongest identity signals feeding the zero-trust feedback loop, enabling continuous risk-based access instead of one-time login decisions. Risk-based access is how PKI-backed identity turns into practical zero-trust decisions. Instead of a simple yes or no login, every request is scored for risk, and the system chooses the right response in that moment. Certificates give us strong identity for users and devices, but that's only the starting point. We combine that identity with context. Which device is this? Is it managed? Where is the user connecting from? What time is it? And how sensitive is the resource? When everything looks normal and low risk, access can be allowed with minimal friction. If something looks slightly suspicious, we don't have to block. We can step up assurance by asking for extra verification, like another factor or re-authentication. If the risk is clearly high, we can confidently block because identity plus context no longer match expected behavior. The key idea is that PKI supplies a cryptographically strong identity signal and risk-based access layers intelligence on top of it. That combination keeps organizations secure against evolving threats, without forcing maximum friction on every single user, every single time. Defense in depth with PKI means we never rely on a single check to protect a valuable asset. First, we prove the device is trusted, using a device certificate tied to that specific laptop, phone, or server. If an attacker steals a password but not the device, they still can't get in. Next, we prove the human is who they claim to be, with a user certificate or smart card style identity. Now, an attacker would need both the device and the user's cryptographic identity. Finally, we verify the device's health or posture. Is it patched, encrypted, and running required security controls? If not, access is blocked or heavily limited. By layering these controls, encrypted device, trusted user, and healthy state, you move much closer to zero trust. Compromising one layer is no longer enough. An attacker has to beat all three at the same time, which is dramatically harder in real-world environments. PKE is incredibly powerful, but it's not the only game in town. In modern enterprises, the key decision is not PKI or FIDO2, it's where each one fits. PKE shines where you fully control the environment, core infrastructure, network access like VPN and Wi-Fi, managed laptops and servers, and older applications that already understand certificates. There, certificate-based trust integrates deeply with your existing architecture. FIDO2, by contrast, is optimized for people-centric access. SaaS applications, browser-based cloud portals, mobile and BYO devices, and external users who will never be joined to your domain. It brings phishing-resistant, passwordless authentication. The strategic target state for most organizations is hybrid. Let PKI continue to anchor device and infrastructure trust, and layer FIDO2 on top for user authentication and access to cloud services. The real skill for architects is deciding which identities live in PKI, which live in FIDO2, and how they work together to support a coherent zero-trust strategy. Moving to a PKI-driven, zero-trust model is not a single project. It's a phased journey. You begin with governance. Clean up directories and identity stores. Decide which systems are in scope. And lock in policies for issuance, key management, and revocation. If this foundation is weak, every later step inherits the risk. Next comes a pilot. Pick a few representative user groups and applications. Prove the flows end-to-end when new abuses and users impact, and tune certificate lifetimes, automation, and support processes before you scale. Then you roll out broadly. This is where training, clear communication, and automation matter most. The goal is to make strong certificate-based authentication feel routine, not disruptive. Only after that can you safely turn off legacy authentication. Disabling passwords or weak protocols is what actually delivers zero-trust benefits, but it's also the riskiest moment. A disciplined roadmap reduces surprises and helps you trade short-term friction for long-term, resilient trust. By now, you've seen how PKI underpins identity, encryption, and trust. So, what does that mean for digital transformation in your organization? First, start planning the end of passwords as a primary control. They're cheap to deploy, but extremely expensive to defend. Your roadmap should deliberately shift high value users and systems to cryptographic credentials instead of shared secrets. Second, prioritize phishing resistant authentication. That means PKI based certificates and modern standards like FIDO2. Both bind authentication to the device and the cryptographic key, so attackers can't simply replay a stolen password or OTP. Third, make access decisions risk based and context aware. PKE gives you a strong who and what device, but you should combine that with from where, when, and for what before granting access. This is how PKI becomes a core engine inside Zero Trust, not just an SSL checkbox. Finally, treat identity infrastructure as a strategic investment, not background plumbing. A well-governed PKI program enables secure cloud adoption, API ecosystems, and workforce mobility. In other words, getting PKI right is one of the fastest ways to make your digital transformation future-ready.